So, kind of give you a demonstration of what I mean by this. I'm going to use two yardsticks here. And obviously they're the same length, but they don't have to be. Okay, they do not have to be the same length. And a lot of times, like I said, they're not going to be the same length. So here I've got just a file folder that I cut in pieces, but that's going to be my angle. Okay. If I were to take this side, this segment, and tape it to my angle like that, and then take this side, put it endpoint to endpoint with that other ray, and match it up the side of the angle like that. Does that make sense to everybody? So I've got a side, an angle, and a side. And I'm forcing these distances. I'm forcing what those distances have to be. I'm forcing what this angle has to be. If you took a third segment and connected that endpoint to that endpoint, would you get a triangle? Okay? So the idea then is disassemble a triangle, flip things around, maybe choose different, maybe flip these two sides around, whatever, doesn't matter. But then I reconstruct, do the same exact thing, and hold that up, and I connect those two endpoints again. Is that going to be the same triangle? Has to be, right? So and I could do that all day long with the same segment, same set of two segments and the same angle in between, and I can get the same triangle to be created all day long. So that's what they're saying here. Okay, and I'm going to give you, we're going to work right here with this a little bit. Okay, so right here, think about this. In order for, I guess, the conclusion that we come up with when we say that the triangles end up being congruent is that all 6 parts end up being congruent, right? All three sets of sides congruent to one another, all 3 sets of angles congruent to one another. Right here, all we're doing here is focusing on that segment, that blue one congruent to that blue one, this green angle congruent to that green angle, and this pink one congruent to that pink one. Okay? And if we put the distances in here, see B is 5.88, E is 5.88A, and H are both 7.35. And now the angle between there and there is 62.69. This one's going to be 62.69. Does that kind of make sense? So there you've got a side, an angle on a side, congruent to a side, an angle on a side. So what I want to do here, guys, is just show you that as I move this around, it's going to kind of force these over here. I'm going to move it around a little bit to get out of the way. But we should be able to, as we change the triangle on the left, which is basically changing, in that demonstration I gave you, it's changing the folder that I use as the angle, and it's changing the sizes of my meter sticks, right? Okay. I want to talk about this black segment right here. I don't know what that length is yet. We'll find it in a moment. But if I were to use these blue, green, and pink parts to create this over here, shouldn't there be, if I take that point there to that point there, 2 points to determine a line, right? And I can use that as a segment now. Okay? Now, I never tried, I didn't even know what this dotted segment's length was. And I never tried to make this black one here, the solid one, the same as that one, right? I didn't even know what that one was. But when I asked this thing to find me that distance, C's distance is 6.74. This distance here, 6.74. You see how they were the same? I didn't try to force that. It just happened because we're using these side angle side components. Now, would you agree that we never worried, I never tried to determine what this angle A was? Angle A ends up being 51.68 degrees. Okay? Well, that's the angle between the blue and the black, right? Let's come over here. That should be correspond to the angle between the blue and black over here. So I'm going to click on backwards. That, does that give me 51.68? I never tried to force that. It's what happened, right? Does that make sense? And then come over here and do it with these. 2 gives me that angle to be 56.19. And this one here, 56.19. Okay? So we started, let me just kind of color all this stuff the same real quick. We started with all of those red things being congruent, right? And it forced everything else up there that's not red to kind of fall in place and be congruent as well. Okay, so then if that's the case, you've got three segments congruent to three segments and three angles congruent to three angles. Those two triangles must be congruent triangles. They're the same thing. Is it okay? So that's what we call the side angle side postulate. Okay? And I think, guys, these demonstrations will end up making a lot more sense when we start seeing examples of orientations or orders of parts that don't work. Okay? So one of those orders will be side-side angle. Side-side angle does not guarantee me to have two congruent shapes, two congruent triangles. And we'll do that demonstration, and it will maybe make those demonstrations seem even more appropriate. I've got another one here, I think. We can do this one. So the idea here with this one is I'm just going to kind of cut and paste that segment right there, cut and paste the angle in that segment there. So this shows kind of rotating to get that angle together. So that image right there is kind of what I did with the meter sticks in the folder, right? Okay. So then what's that going to mean? That means that I should be able to take that triangle and put it in there, and it fit and make up the same thing as the triangle I started with, right? Okay. So that's the side angle side postulate. Okay. Now, what I want to do, we got a couple proofs here that I want to work through to kind of use this. And what my hopes are is that, well, we'll do this proof, and then we'll talk about this at the end, what the purpose of this is. Paul, I don't know, that glare on the board right here. In 6 years of being in this room, I've never been there, so I don't know how to get rid of it. We tried shutting all windows, opening all windows last period, and wasn't doing it. Those little rectangles down there should be triangles. So we're going to start with AB congruent to DC and angle BAC congruent to angle DCA. Something I would do, guys, I know that I've been in your seats, I've felt the same way, I still kind of feel the same way. Writing these proofs can be, just kind of tease the amount of writing that we have to do, right? Most people don't like to just write things, okay? If you want to clean things up, if you want to kind of expedite the amount of writing you have to do, you already wrote this down as your given, right? Okay, in the setup of the problem. If you want to come down here and step number one, and just kind of in parentheses maybe put given there, and then write this, so that's the only thing you write is given and given. I would think that would be appropriate for your notes, because then you can kind of reference back up to what the given was. Does that make sense? It might eliminate you having to write a large amount of information. Now, some of them is not a big, I don't think maybe this one's all that big of a deal. But some of them are sentences, some of the givens are sentences, some of them are 2 or 3 sentences. That would be kind of tedious. But if you remember, when we're working with these proofs, the number one thing you want to think about when they give you given information is to see if there are any congruencies. Going back to that sheet that had 7 steps on it, first thing was write down your given, and if there are congruencies in the given, draw that in your picture. So I'm going to find AB in my picture, that segment there, and DC, that segment there. And we're going to make the markings that they're congruent. Okay, so that would be that first one. Now I'm going to do the same thing for BAC. Angle BAC and angle DCA. I make those markings. And now the reason we do that, if I were to, just to prove a point here, if I were to just cover all this garbage up right there, okay, and, maybe I left that picture there. And I would ask you, okay, what other thing, looking at just statement number 1 right there, we got written in black, and I would ask you to look at that and say, well, what is the next thing you need to show these triangles congruent? That's kind of hard to think about. It's kind of hard to organize that information without a picture. But if we're updating our picture, like we should be, when I look at this picture here, eventually the hope is that we've done enough of these that we realize what we're supposed to find. We have 2 tools right now. We have side, 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 and side, angle, side. Those are the only things that we have right now at our disposal to be able to prove triangles congruent. Okay? If I want to go side, 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 think about this. Right now, I've got one set of sides congruent. So maybe I got that S there satisfied. And if I want to continue with side, 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 don't I need two more sets of sides to be congruent in there? And I'd have to be able to pull that out and figure that out from that picture. That might not be the best thing to do. Okay? Well, if I look at this side here, okay, so that S could be that side and that side. And now the angle could be that angle there and that angle there. Does that make sense? So right now, if I'm looking at the parts that my given provided me, they give me S and A, right? So does it make sense that if I want to try to prove these triangles congruent, that one's probably not the best option. SAS is probably the best option. Okay? If that's the best option, then I need another side, right? I need to be able to show another side congruent to another side. There's really 3 ways that we can show geometrically right now that sides or segments are congruent. One of them is using a midpoint. Okay? Being able to, if they tell me I have a midpoint, or even a bisector, because a bisector involves a midpoint, if they tell me that information, then I can say segments are congruent. If I can do some segment addition, and take some algebra and stuff like that, and several collinear points, I can say segments are eventually congruent. And the other way is to say that a segment is congruent to itself. Okay? And the only time that I want to do that is ultimately when I look at my picture, and I've got 2 triangles, and there's a segment that is being shared by both triangles. Is there a segment up there that's being shared by both triangles? What's that segment? AC, right? So what I want to do is write that AC is congruent to itself. When I do that, it allows me to come to my picture and just put 2 marks in that. Okay? And if I focus only on this yellow triangle here, what is the order of the parts that are marked in that yellow triangle? Starting with the black segment with 1 hash mark in it, it goes side, and then it goes up to angle A, which is an angle, and then it goes to the red 2 marks, that side, which is another side, right? So is that order side, angle, side? Does that make sense, everybody? So we see how this angle right here is the included angle that we were talking about up here in questions like this one and that one. Okay? So we've got an included, we've got side, angle, side in this yellow triangle. Okay? Now what we have to be careful of is, do we have the exact same order in this triangle? Because remember, it says 2 sides and the included angle of 1 triangle congruent to the 2 sides and the included angle of the second one. So we need to have the same order in that blue triangle. Do we have a side followed by an angle followed by a side? So in this one here, we got side, angle, side again. When you're able to recognize that, you have 2 triangles that are congruent. Okay? So one of the One of those steps on the handout that I gave you said, all right, just kind of go through those steps. First thing said, write all your congruencies down that were in your given. Second thing was look at your vocabulary. Go through your vocabulary. Well, there are no vocabulary here. Okay? So we kind of skip that. The third thing is to look at your picture and see if there are any hidden congruencies or hidden truths that you can see from your picture. But when we're trying to show triangles congruent, one of those hidden things is usually the reflective property. It's usually what is being shared in its entirety in that set of triangles. So we say AC is congruent to AC because of the reflective property. Okay? And now all of these rules that we have that are side, 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 or side angle, side, there's going to be a couple others later on. We can start using those once we figure out we've got one congruency, two congruency, three congruencies. Does that make sense? Would you guys agree, just with a yes or no, if I were to give you this stuff right here, if I were to give you that, but I did none of this, I never updated my picture, but we had this stuff here, would it be hard to realize that these two triangles should be congruent by side angle side? Does that make sense? It's a lot easier to see it that way and to know that they should be congruent because we can visually see it without having to look at all these words over here, right? You've heard a picture says 1,000 words, right? And that phrase before? That's the idea here. This picture says more than what this does to it, okay? And in regards to allowing us to make a conclusion. So now I want to name these triangles. Okay, so what do you want to call this yellow triangle? What's the order of points you want to use? There's no wrong answer here. BAC? Okay. So I named that one BAC. So now I got to figure out how to name the blue one. So I started at B, had no marking in it. And I went down a segment that had one mark in it to get to A, right? So then A was the angle that had one mark in it. So to follow the same pattern, where do I have to start over here in the blue one? I have to start at D, good, and then go to C. So you go D to C, and then obviously you know you have to finish then at A, right? The reason for that, why do I know these two triangles are congruent? We have the order of parts of side angle side. A side, an included angle, and a side congruent to a side, an included angle, and a side, and another triangle. So triangles are congruent. So that's all. That's just 3 steps. Okay. Every proof that we do for the next several months, okay, and even towards the end of the year when we start doing proofs, their foundation is going to be this. Okay. The first 3 steps, 4 steps, 5 steps are going to be showing triangles congruent. Okay. So understand, my hope is that we can kind of connect the dots and the idea. I don't want you to come across this problem 3 weeks from now and think it's a brand new problem. Okay. Or a proof 3 weeks or 4 weeks from now and think it's a brand new proof. Because the first 4 or 5 steps are going to be what we just did here. And then we'll add 1 step to it to address that new problem, or add 2 steps to it. So what I mean by that is eventually the question will be, can we prove this thing to be a parallelogram? Okay? So here's my argument. If this is a parallel, if we want it to be a parallelogram, we need some parallel sides, right? Well, what do you know about that? We knew that angle right there and that angle right there were already congruent, right? Would you guys agree that that side, and that is a transversal? Does that make sense? What kind of angles would those be? Alternate interior, right? If alternate interior angles are congruent, doesn't that make the lines that form them parallel? Does that make sense? Okay. The next thing I would do, so now we know that side and that side are parallel. That doesn't make a parallelogram. That's a trapezoid right now, based off the definition of these things. If I look at that angle right there, is that angle congruent to that angle? And the reason we know that BCA, B to C to A, which is that angle there, does that match up to DAC? D to AC, that angle there. Does that make sense? So those would be congruent because the triangles they came from were congruent. Now, could you argue that that line and that line are being cut by that transversal? So could that tell me that the top and bottom line are also parallel? Because these angles are alternate interior as well, they're congruent. Does that make sense? So when I ask you down the road, 3 weeks, 4 weeks, 5 weeks from now, to prove that shape up there, that blue shape is a parallelogram, your first 3 steps are going to be that, something we did today. They're going to be exactly that. Okay? So as we move on to other chapters, the new problems start off using the old problems. Okay? Right now, obviously, we're focused on trying to show the triangles congruent. I want you to see where this is going to lead us. Okay? We can do a similar thing with this one. Okay? So this will be the last one we do. So I'll give you a couple minutes to write that down, and we'll reconvene and discuss what we're supposed to do there. Okay. When we do these, guys, the main thing that we usually look at in any proof, just to get the ball rolling, is obviously the given, right? Okay. And remember, the given phrase, along with the picture is part of the given, kind of drive the process. Okay. When you have triangles in your picture, I'd say probably 95 to 98% of the time, you're going to want to try to prove those triangles congruent. Okay? Now, here's the thing. If I end up showing these triangles congruent, so I have like triangle ABC congruent to maybe triangle ECD or something like that, does that match up to what I'm trying to prove in this problem? My goal, this does not say a triangle congruent to a triangle, right? It says an angle congruent to an angle. Okay? But the only way that I can show angle A, that angle is there, to actually be congruent to that angle right there of E, is to first show that the triangles that they come from are congruent, and that A and E kind of match in terms of their position in their triangles. Does that make sense? So the first thing, even though this prove statement does not say prove triangles congruent, that's the first thing that we're going to try to do. Okay? So when we try to prove triangles congruent, you kind of want to take it as I view it as kind of like a game, okay? They're going to give me all the necessities that I need. They're going to give me all the congruencies that I need, but they're not going to be explicit about it. And what I mean by that, if I go back up to the last example we did they tell me one of the congruencies that I needed right there? That's pretty explicit, right? It's pretty straightforward. I didn't have to do any thought or any work to find that congruency. They gave it to me. Same thing with that one. The only congruency that we had to kind of think about and kind of uncover was that one right there, right? Okay? What they will do is kind of play that game with you. Sometimes they'll give you straightforward information. Other times they'll hide it. They'll hide congruencies through definitions, postulates, theorems, other relationships, and so forth. So this one, they hide all 3 congruencies that we need. Okay? So when I look at this, the first thing we're going to do is read through our given and see if there's anything we can add to our picture. Any congruencies. There are no explicit congruency, so I can't do that. The next thing I do is I look for vocabulary. What's the vocabulary word in here? Midpoint, right? And what you need to do then is identify what a midpoint means for our particular problem. It says it's the midpoint of AE. So C is the midpoint of AE. Does it make sense that that distance there and that distance there has to be the same? Okay? So for our specific problem, we're going to write that AC has to be congruent to CE. And remember, if I use a vocabulary word to get a conclusion, it's usually the definition of that vocabulary word as my reason. Okay? Now, that's nice. That's one set of sides congruent, right? In my either, whether we're going to use side, 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 or side, angle, side, I now have one of the S's in those acronyms satisfied. Okay, I got one congruency down. Now I need two more congruencies. Well, not only was it the midpoint of AE, but it's the midpoint of BD, right? If I highlight BD, that's that segment. So doesn't C have to be a midpoint of that? So doesn't C break that up into two congruent parts? Okay. So I get BC congruent to CD. And it's still because it was a midpoint. So I'm going to write all that under step 2 with reason 2. We had a discussion in the last class. I said, well, how come in the yellow ones you put 1 mark, and in the red ones or orange ones you put 2 marks? And the reason for that is I don't know that all 4 of those smaller segments up there are equivalent or not. The only way that I would know that I could maybe do something like this. If I do that, that tells me all 4 of these little segments are the same, right? The only way that I would know that is if they would have told me at the beginning that the yellow segment AE was actually the same length as the big segment, or the orange segment was BD. Does that make sense? Okay. But I don't know that, so my assumption is that they could be different. AE and BD could be different. So I don't want to make sure that when I cut them in half, I don't want to say that all 4 parts are equal. Does that make sense? Okay. So that's why we use 1 mark and 2 marks in this thing. Okay. So right now, we've got 2 congruencies, right? So if I'm thinking about the tools we're allowed to use to prove triangles congruent, I've either got those 2 S's, or maybe I've got those 2 S's. Does that make sense? I've got some options here. Now, if I want to use side, 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 the third side are these blue ones, right? Showing sides congruent, guys, is very difficult. The only thing that we can do to show sides congruent is use a midpoint, use segment addition. So there's nothing there like AB. There's no other third point I can use to start doing segment addition. And the other part is the reflexive property. Basically saying, is AB in both triangles, or is DE in both triangles? So that's not going to work, right? So I can't use side, side, side here. I can't show those third sides congruent. Okay? So if that's the case, if I can't use that, I must have to be able to use this, right? So what would be the angle that is between these 2 sides? Okay, it's going to be this angle here, right? What's going to be the angle that's between these 2 sides? Should be that one there, right? Okay. Now, I don't necessarily want to call them C, because when I say C, there's really, I don't know counting them, but there's at least 1, 2, 3, 4 angles there that have a vertex C, right? And there's some straight angles there that also have vertex C. So, I think there's 8 total angles there that have vertex C, so I don't want to just say angle C, because we'll all be looking at different things. I would want to talk about them as like ACB and ECD, right? Does that make sense? Use 3 letters. But before I say that, before I talk about why those are congruent, or before I name them to be congruent, why are they congruent? What kind of angles are they to one another? Vertical. Okay. So always be on the lookout for vertical angles in these questions. Okay. So I've got angle. I guess I'm gonna call it ACB. ACB. Remember, that just gives me a tool to trace out that angle that I want to talk about. And another one I'm going to call ECD. Start at E, go to C, go to D. Both those names trace out those two angles right there. Okay? And the reason then is vertical angles are congruent. Both phrases. So the vertical angles theorem actually says in its kind of substance, it says vertical angles are congruent. Okay? So either one of those phrases is fine, right? So what's that tell me then? Do you have a side and another side with the angle that is sandwiched in between them? Is that a side angle side relationship right there? Do you have a side and then the angle and then the next side right there? So are those two triangles congruent? So I'll name them. I'll just name the one on the left, ABC. There's no wrong way of naming that first triangle. And you could have started with the one on the right if you want to, but if I went A to B, that started at the vertex with nothing in it, went down to the vertex that had, again, nothing in it, and then it followed down the segment that had two marks, right? If I want to follow that pattern, do I start at D, go to E, and then finish at C, or do I go from E to D to C? E to D, okay? E to D to C. And the reason will be because of that order that we had, it was side, angle, side. So whenever you make a statement right here of two triangles congruent, your reason right now will be three letters, SSS or SAS. Okay? Now, does that match up with what we wanted to prove? Nope. But if I've got these triangles congruent, is that and that the first letters? Any of the first letters, right? So they match and they're in order, right? So I can say angle A is congruent to angle E, but now I got to come up with a reason. And if they match, what's the mathematical word for matching positions or something like that? Corresponding. Okay? They were angles, right? A and E are angles, but collectively, angles and sides are referred to as parts, correct, of the triangle? What was the relationship between the triangles that they came from? What do we say in part 4 there? These triangles are what? Congruent. So we have matching parts or corresponding parts that came from congruent triangles. And what's the conclusion I'm making about those parts? They're congruent, right? So corresponding parts of congruent triangles are congruent. And that's our CP-CTC statement. I don't want to write out corresponding parts. Congruent triangles are congruent. That's the acronym for that. Does that kind of make sense? Okay. So here's the thing. Down the road, in might be a couple weeks, might be a month, whatever, we're going to see a question like this again. But instead of this, instead of A congruent to E, they're going to say, show AB parallel to DE. Now think about this. I'm just clean some stuff up here in my picture. Did we just prove these two triangles to be congruent? Did we just show that congruent to that by CP-CTC, right? If I focus solely on that segment, and that transversal, are those alternate interior angles? Are they congruent? If alternate interior angles are congruent, then the lines that are forming them have to be what to one another? Parallel. So when I ask you this in a couple weeks, my hopes are that you don't view that as a brand new question. My hopes are you say, oh, to answer that, I'm going to write these 5 things that I've already done. I'm going to go back to this proof, this old proof. I'm going to use those 5 steps in this new problem, and then I'll attach one step to the end of it that basically says AB is parallel to DE, because when alternate interior angles are congruent, the lines that form them are parallel. Okay? So that's the idea. I don't want, and that's mathematics in general, guys. I don't want you to come across a new subject, a new chapter, a new section, and think this is brand new. There's no tie-in to what we've already done. There's always tie-in to what we've already done. Okay? You should never start a new problem from scratch. Okay? There is a homework assignment over this stuff. There's not a lot of proofs in it.